So today what we're going to do is we're going to continue looking at plotting points on the Cartesian plane, but today what we're going to do is we're going to plot what are called linear relationships. Okay? Now, we've discussed linear relationships before when we looked at patterns the first time where we were writing a rule. Remember, we would find a rule for a specific pattern by first finding the common difference and then finding out what we needed to either add or subtract to that common difference to make our pattern work, right, for every value. And we're going to look at a little bit more of that today in case you've forgotten, because it will be on this assessment. Okay? But more importantly, what we're going to do is learn how to then take those tables. Remember, we were making those tables of values, and take those tables and plot the values and make a linear relationship on them. So in other words, we're going to draw a picture of those linear relationships. Then we're going to use that information to be able to expand, go further back, go further down, or look at different values that we may not have on our chart. Okay? So the first thing I want to talk about is the word linear. You know that something is linear because when we draw the picture of it, it's going to make a what? Straight line, exactly. And they have a relationship because they can be described using a pattern or a rule. Okay? So we're going to start off with these, looking at the pictures and the charts, and then we're going to move on into using equations to work with it. So you're going to be using your equation solving skills from the algebra sections as well. Okay? All right, so let's just go to the Education Perfect because they draw better than I do. Yay. Here we go. All right, so wait a minute. Hold on a minute. Thinking that I want to do this homework and I don't want to do that. So plotting linear relationships. So if you'll remember these, you have a pattern that's made up of blocks or pictures of matchsticks or whatever. We could also have it represented using a table. We could also have just a sequence of numbers where you always know the first one is, all right, so that would be 1 and 3, 2 and 5, 3 and 7. Where am I getting the 1, 2, and 3?
The
first number, second number, third number. Remember the pattern? Or you can have a rule. And since that rule has an equal symbol in it, that makes it what kind of algebraic sentence? An equation. There you are. Remember that if it has an equal symbol in it, then it's also an equation. Okay? So what we're going to do is we're going to look at how to represent these types of things on a graph, on the Cartesian plane. And it's very simple because we've built our background on this, knowing that you simply plot your x and your y. Okay? So let's talk about it, and then we'll write down some steps that'll make us to be able to do any of these. So here you go. A graph is another way of showing a pattern, so we can draw it. We have our relationship. The first number is a 3. Second number is a
5.
Then 3 and 7. These correspond to ordered pairs, where the first number is our x value and the second one is our y value. Okay? So in this case, for this particular one, x would be what number? 1, and y would be 3. Okay? All right.
Wait,
So we're going to correspond.
It's in x or y?
And the first one is the x value, the second one is the y value. Okay? All right. So what happens is, if you change this one, it changes the other one, right? So the third number is not the same as the first number. Do you agree?
Yes.
And we got these numbers by looking at the pattern above it. So what's happening here? Each time we increase the number, we increase our bottom number by 2. So there's a common difference by 2, twice as much. We actually looked at this one, I think, when we did that. So this is a linear relationship because they always change by exactly the same amount. Right? Okay. So, and we called that before when we're looking for those as we called it a common
Denominator.
Difference. There you go. Every D word you've ever heard, right? So that's good. I love it. It's fine with me. Okay? All right. So, if you look at this Cartesian plane, notice they've given you the x-axis using the letter N and the y-axis using the letter T so that it corresponds to the way those things were built in the chart, right? Now, you can change them to N and T. You could call them X and Y. The name does not matter when you're just talking about numerical relationships. Now, but say I was talking about time and I was talking about money. Those variables may want to be more specific so that you make sure that you're getting the right thing in the right spot. Okay? So, but if you're just using N and T, you could just as easily use X and Y. I'm perfectly happy with that. Okay? But remember which one's which. So here we have a chart. Now we can plot them on the Cartesian plane, remembering that they're simply ordered pairs. So if I was going to plot these on the Cartesian plane, remember that's just two sets of number lines. So 1, 3 would be the same as the ordered pair 1, 3. So that means starting at the origin, I would go where? Don't say over.
Right.
To the right. How many units? 1. And then what? Up 3, because it's a positive 3. So that would give me the point 1, 3. And if we were just plotting points, we would label them. But what we're doing is we're plotting a picture of a rule. So you wouldn't label each individual point. Instead, what we'll do is we'll call the entire line by the name of the rule. Okay? So let's just plot our second one on our little graph we've got going here. I know we're going to be messy, but that's okay. So 2, 5 means starting at the origin, I'll go where?
Across.
To the
Right.
To the right 2, then what?
Up 5.
Up 5. There you go. Right? And that is exactly the language that you need to think in. Right? Right or left, then what? Up or down. Okay? So just for kicks, let's do the next one. Starting at the origin, I'll go where? Be careful. To the what? To the right 3, then what? Up 7. And even though my graph is a little wonky, what do you notice about all these?
It's a line.
They're making a straight line. And we could continue that straight line all the way from one edge of the graph to the other. What that means is that even though our chart doesn't show an infinite pattern, we know that as long as we can continue it in a straight line, it will go infinitely in either direction. Okay? What's going to happen if I had the number 0? What would happen is these numbers are going to start getting what? Smaller. Including they would continue to go down into the negative numbers, right? Which is what this side of the graph is showing you. Okay?
That's a negative square.
Mm-hmm. Well, negative, huh? Negative. Okay. I don't know what that means, but okay.
No, the negative square,
Okay.
the one that's always negative because it's negative that way.
Yeah, that's what I meant.
Oh, the negative. Okay, I see. Yeah. So down here, they're always the negative and negative.
Yeah.
Okay. Well, let's give it a name. The four sections are called quadrants.
So it's the negative.
Okay.
The negative.
And because there are exactly 4 of them, and they actually have names. They're numbered.
Wait, there's 4 what? What's the 4?
4 quadrants.
Oh, what are quadrants?
Each one of these is a quadrant. And the quadrants start here where everything is positive. That's quadrant 1. Shh. Okay. Oh, what are you doing? Oh, you're doing graphing.
Just do the
Okay. I'm sorry. Then I won't shush you. Then that one's 2. This one's 3, and this one is 4.
Why don't they go clockwise?
They go anti-clockwise.
Why?
Because think about what happens up here.
No,
X is always what sign? Positives. And then down here, the X's are always negative. So they follow where the X is positive. This is X and Y are both positive. X is positive, then negative. And these are where they're both negative. Here, it's negative, then positive. Okay.
Yeah. So
All right.
that's the negative square, and the top one is the positive square.
So it just goes anti-clockwise. Most of the time, you would anticipate it being clockwise, but it's not. Now, also notice that they're named. These aren't Arabic numbers. They are what? Roman numerals.
Arabic numbers.
Yeah, like these. That's an Arabic number. Right? Okay.
Is that how you're supposed to write number 4? Wait, so normal? Isn't it 1V?
It is one. That is 1V. It's just very.
Wait, we are looking
okay.
right now.
Oh, why do you put the lines on top?
Yeah.
We always do it without the hands.
Ah, it's just tradition. Okay. All
I
right.
thought it was just like eyes or something.
Okay. All right. So you'll see they plotted the first one and then continue to plot them. What do you notice about all the dots?
They're going up.
They make a straight line, and they're also going up, which tells you that these are always increasing. Which, if you notice our pattern, what's it doing?
It's increasing.
Always increasing. Yeah. Good. Right? So then you can draw a straight line.
Let's get plotted. Let's get.
Okay.
Think you've got all that? I sure do.
All right. Good deal. So we can plot some of these.
Yeah.
Now, pardon? All right. So you're going to be plotting some and doing some of those where you're going to plot the points and then draw the line. We can also plot these lines by looking at the rule. And this is the part that we need to focus on. Whoa, I don't want to do that.
Cancel.
Let's cancel that. Okay. Whoa.
Is that
It's an incredibly
In-
was that?
NCA stuff. All right, so, yeah, and those stupid reports. I hate those things. Do y'all read those?
Yes,
My parents sit down and close me.
Do they?
And my
I
I make sure that I can read my report for my parents so that I know whether I read
I want
Doesn't
to
read
read
that.
All of you get perfectly wonderful reports, I'm sure. Yours are always. All right, come on, focus. Okay, so here what we're going to do is we're going to learn, okay, to plot
We did all this last year.
a rule, an equation.
You find a common factor.
Huh? You're in your common factors.
Find y. Because it probably doesn't give you what y is.
Okay.
So you use the rule of
First, okay, what we're going to be doing is, and what I expect to see, guys, what I expect to see is that you're plotting these rules by creating a chart. We're going to create a chart, right? To create the chart, remember that these things are linear. That means they go in both directions infinitely. So it doesn't matter what values you choose to create your chart. And you don't need, they usually use 5 or 6 values. You really only need 3. 2 to give you where the line, what the behavior of the line, and 1 to make sure you didn't make a mistake. Okay? So, first part of choosing. Choose any 3 values for x, which they often call n, but I'm going to call it x.
This number.
The number, yeah. Okay? Now, again, what values? Any of them. I always choose the same ones. I always use 0, 1, and 2 with these, but you could always use any number. You can use any numbers you want to.
Would that have to be consecutive?
No. But those are easy to work with because 0 is very easy because multiply by 0, it's going to go away. Right? You're going to have to solve the equation. Okay? All right. B. Substitute those values into the equation or rule and solve for the y. Yeah. To get y, which they call capital T. Okay. Later when we move into equations, it's going to be x and y, so you might as well just get used to it now. Yeah?
But do I need to write
Same
this
thing.
down?
I don't know. Do you normally take notes in my class?
I haven't been taking notes for the last like.
I've got no more room.
I
In my,
already have.
don't throw.
Somewhere else.
I actually do throw, but not in my eyes.
All right.
And it's a break.
Do that 3 times.
Is this 2?
So all 3 values, each value of x is going to return a specific y value. They never repeat, all right, for linear patterns. So you need to make sure you do it for all 3 of those values. Okay? Then you're simply going to plot the resulting ordered pairs. You'll have x values, you'll have y values. If you have an x and a y, that means you have an ordered pair, which is a point on the Cartesian plane. Right?
Wait,
So
so
create a chart and then plot the resulting ordered pair.
That's it.
2. Wait. Plot.
And step 3,
I'm going
draw a line from edge to edge. I'm going to just cram it on the bottom because I want to keep it on one page if I can. Now, that means from one edge of the graph to the other, because these things are infinite. They go on infinitely. There will be some where all you're interested in are the positive ones, and you'll see that. They'll give you those graphs, but for the basic graphs, they need to go from edge to edge, right? And, of course, they need to go through the what? Through the points, right? Okay? And that's the reason you do 3 values. Yes?
Can't you just do the little lines to show that it keeps going?
You can, but you don't
The
need to.
little arrows instead of going through it from each edge.
You really should draw it from edge to edge. You can put arrows on it. That means the same thing, but we're going to be reading information from these, and so you're going to be reading, so you might want to have to extend it then.
Okay.
So it's better to just go from edge to edge, which indicates that it goes on infinitely.
wait, what's T?
T, remember the chart, when they give you the chart,
Oh,
they give you N and T.
I get it now.
We're going to call it X and Y.
Oh, I thought it's the other way round. No, wait.
It's that way round. There's no other way about it. It's that way round.
No, what?
There's no report explaining why you did
Why? No, I thought X was at
Oh,
the
why?
bottom.
N equals
First one is always,
because.
the first one is always which one?
X,
And the second one is always,
Y.
there you go. There's your explanation. Look how happy you are.
No, but on the graph, that way, on this side, it's like this. Oh, wait, yeah, I see what you mean.
Caitlin,
Wait, no, I don't
okay.
Not anymore.
It's all right.
The fact that N is X and that T.
Just let it soak in.
So when you go on that page,
Okay.
since it's the measurement,
It's alright.
All right. Are we good? Everybody ready to look at some of these?
Oh, yeah, I see what you mean.
All right. So here we go. So here we have a rule, which is also the same as an equation. We know it's an equation. Why? As an equal symbol. Excellent. Okay? And so we can use that rule to plot the relationship. Now, so what they did was they chose 5 numbers and plugged each one into the original, substituted each one. So here they did the 1, right? 2 times 1 is 2, minus 1 gave you 1. So if it's the first number is 1, the second number is also 1. Okay? And then they just continued on. You do not need to find 5. 3 is plenty. But you do want to find, guys, shh. But you do want to find at least 3 because you need to be sure that you didn't make a mistake. If you're plotting your relationship, hold on. If you're plotting your relationship and you get a point here and a point here and a point there, do those line up in a straight line? No. So that means you've made some kind of math mistake. But you're not going to really know what should it have been there, or there. So that's why we do 3 of them to be able to check. Okay?
We call this relationship advice with Mr. Sam.
Please.
If you're plotting your relationship.
I don't want any more classes after lunch, ever. Huh?
Can you go back to the Lycas part?
Did you get it all written down, Kath?
Yes.
Can you share with Caitlin so she can finish? Oh, you took a picture. Okay. All right, here we go. All right, come on. So once you have that, you have your X's and Y's. You can simply plot them and draw your line.
Look at that octopi.
It's a jellyfish.
Jellyfish.
Well, okay, so it's an octopus.
Okay.
If there's one octopus, you wouldn't call it an octopus.
So here we go. Are you ready? Everybody gets to play. So, it's the only way I can make y'all pay attention. Don't know. Must be. All right. Okay, guys, come on. Here's our rule, and we know it's an equation because it has an equal symbol. So what we're going to do is we're going to make a chart. I usually make my charts up and down. You can make them any way you want to. I don't care. Now, what I do care about is that you choose at least how many values? 3. If they give you a chart on an assessment and it has 5 squares in it, that means they want how many? 5. Do not cheat. Yeah, so, and you can choose any values you want to. And they can be in order. It doesn't make the slightest bit of difference. You can use 0 if you want to. It makes no difference. I like to choose 0, and let me show you why.
Wait, what's cheating?
To not use as many values as they give you. If they give you a box with 5 squares in it, you use 5 values or I'm going to count it wrong. But if you're allowed to choose your own, then just choose 3. Okay?
So when you make your, so is it when like they?
So like here, they didn't give me anything but the rule, so I can choose 3. But if on a test they gave you a chart to fill in, and it had 5 places in it, then you need to do all 5.
So if it's kind of wrong, we'll be like, Mr. Self told us in class we only need to use 3. So
Mr. Self will be grading it, so he would know.
do all the numbers you choose have to be like equal distance.
Nope. I could have chosen 0, 192, and 3,575, but that would be a big graph.
500.
Oh.
So if you keep the numbers small, not only are they easier to work with, but it also keeps your graph smaller. Right? Okay. So all we need to do is take each one of those and substitute it into the equation. Right? And I've written x, but that corresponds to the n value. Here we go. I'm going to test you guys. Come on. So the first one is 0. So -3. I'm going to substitute that 0 in place of n. Can anybody remember what must happen when you're substituting? Brackets. Y'all are so good. Thank you. Okay? And now you're going to see why I love 0. What does -3 times 0 make?
0.
So it simply disappears and gives me t equals what?
13. But what if you substitute in a 1?
Well, then it's going to give you, that's different than 0. Every time you get a different value. So now let's do the 1. So it's -3 times 1 plus 13.
3 times 1 is...
-3 plus 13, which is 10.
So,
How do you do -3 times 1?
It just stays there.
Negative times a positive is negative. 3 times...
That means it's still...
There you go. -3 times 2 plus 13 gives me -6 plus 13, which gives me what?
that was Julia.
That wasn't me. I'm actually doing the work. If you can tell.
Okay.
Self, do you want to jump out that window?
Yeah. You draw a hangman and then put my face on it.
Okay. Now, guys, come on. Now look at it. you have really big numbers here, so I've drawn, and none of them are negatives, so I just pretty much left the negative at the bottom out of the way, so it doesn't really matter. But if you see 0, 13 is going to already fall off my graph, right? You see that? So I'm going to do the best I can, and I'm going to put it up there, but it's going to land in my chart. 0, 13 means go up how many? So right or left, none, and then up 13.
That's going to be on the line.
So it's going to be up there. All right. It is what it is. 110 means go where?
Across
Across
To the right one, and then what? Up 10, so right there.
Gotta go over 1.
Not over. 2, 7 is what?
Across 2, up 2. Yeah. I mean, to the right 2.
To the right 2 and up 7.
What if I say over to the right?
where's the point on there?
Okay. And then, do they all connect to make a straight line? So I just draw my straight line from one edge to the graph to the other. It would help if I had a ruler. All right. Sorry about that.
Nice line.
Hey, get a grip.
Can I go into another quad?
Yes, they will cross over and go to another quadrant. Okay? There it is.
Don't worry, your circle is sorry.
Good. Thank you. There we go. All right, so get out your computers. There you go. I expect everybody to be working on it. You don't have new assignments. You have this assignment. So sign in, start working on this assignment. If you vary from this assignment and go to another thing, then I will simply...
Kill you.
No, I'm not allowed to do that, and I wouldn't do it if I could.
You said I'm not allowed to do that. It made it sound like you would.
Would you do it?
Absolutely never.
I don't believe that.
You don't believe that?
I believe it. I consider myself a severe kind man.
No, but... I would certainly be happy to give detention for those of you who don't want to do the homework.
That was self.
Oh, why did you do the blue one?
Oh, that's too
You edited
I'm
the
so
blue
ready to
one.
have like 15 over you. What is that
Was that science?
No, they're not. You have to do them because y'all were driving me crazy and you wouldn't stop talking and playing with pencils and doing whatever. So,
I was trying to write it down, but then
She was not listening, so I was doing it for her.
no, I was trying to write it down.
are you trying to blame Poppy for your behavior?
Yes, that's because Poppy kept on trying to steal the thing off me while I was trying to write. It is so true, Poppy.
She
More working, less talking.
Oh, yeah, that
That is easy.
Why is it getting not putting it not logging me on and I need 100% before noon?
It's possible. Sorry, you missed your deadline.
Okay.
You missed your deadline.
Sonari.
Oh, sorry. in is which axis? In is the x-axis. Got it. So that means I go across y.
Yes, ma'am.